All right, everyone. So it's always great to see all these names and faces. And welcome to part 2 of 3 of our month-long webinar series on mastering the nuances of InBrace. Last week, we were talking about the clinical approach to InBrace, and thank you everyone for attending and for your support. This week, we're having part 2 on digital smile design. And we had part 1 of this earlier this week, so this will be part 2 of part 2, which is the smile design component. Again, this webinar comes from high demand from many of you. So the most important thing that you can do for us is please take the survey that we will send you later on. Give us honest feedback so we can ensure to continue giving you the high quality education material that you need to be successful. Today's webinar is going to be hosted by Dr. Robert Lee, our head of clinical affairs and one of the InBrace co-inventors. Hi, Bobby. And we're also joined by Dr. Tara Poole, clinical director of InBrace and InStudio. Say hi, Tara.
Hey, everyone.
So a lot goes into these webinars. So Dr. Tara is going to help me moderate the duration of this webinar. Feel free to use the chat feature to ask any questions or to raise your virtual hand, and we will be sure to call on you. So with that, I'll go ahead and hand the stage over to Dr. Lee.
Cool. Thanks, John, for the introduction. So today we're doing a mashup of our What's the Future and Mastering the Nuances of InBrace webinar series, where we're going to go over part 2 of a 3-part series on the digital smile design portion of InBrace. For those of you who don't know me, my name is Robert Lee, as John mentioned. I'm the co-inventor of InBrace. So I've been involved with InBrace since the very beginning, about 10 years ago. And then my current role with the company is I'm the head of clinical affairs and senior clinical advisor, where my main roles are to lead the doctor education, advise on product development and clinical protocols, as well as manage the clinical case reviews. Some of the educational content I've worked on are helping write our initial textbook, The Fundamentals of Program Non-Flighting Mechanics, a few years ago, as well as creating the fundamentals of InBrace mini residency. With Gen 2, I was the principal investigator of our initial clinical trial, and then at this point, I've treated, reviewed, or advised on more than 1,000 InBrace cases. Outside of InBrace, I did my residency at UCSF. That's where I still continue to teach there remotely. And then I did my DDS and bachelor's in engineering at UCLA. That's where actually I met John and Dr. Tong in the beginning. With our team, as well as with Dr. Andre, we published a lot of papers. So at this point, I've published over 20 papers, and many of which actually have been on the cover of AJODO or JCO. And then I do practice as an orthodontist at InStudio, which is our center of excellence and learning center for InBrace, as well as at Big Smile Orthodontics, which is the main practice of Dr. Tong, who's the main inventor of InBrace. So at this point, we actually have a fairly large clinical team of internal orthodontists. Dr. Tong, Dr. Andre, John, Dr. Poole, and several others. So we actually have a team of almost 10 orthodontists now, and we're really committed to providing high quality orthodontic education. So we're all working really hard at really ironing out the clinical protocols, as well as distributing out this information that we know, because we know how to treat very predictably and efficiently with InBrace now. So it's just a matter of kind of spreading the knowledge that we've been able to gain for the last several years. So we're trying to do a routinely Facebook post now on the in group. So we do a post every Wednesday. We call it What's the Future Wednesdays. We're trying to add more clinical guides, as well as increase our self-guided virtual courses on learn.inbrace.com. So some updates, some new releases. We are going to be updating the fundamentals of InBrace mini residency in the near future with updated modules on the smile design in particular. As well as we're coming out with a smile design reference guide. So that was by popular request, where a lot of people had told us that the videos are great, that they teach you guys the basics of InBrace overcorrections, but it was hard to remember and then have to reference back to the videos and find it through the video. So many providers asked me to create like a reference guide that kind of calls out the main components that you need to remember. So we also developed this in conjunction with Dr. Scott Schwartz, who really helped us, guide this as well. So in this webinar series, we're going over 3 parts. The clinical approach, which we did last week. Today, we're going to go over smile design. And next week, we're going to look into some case studies. I wanted to kind of set a good foundation for everyone. So a lot of this, I would say, is creating the foundational systems to predictably and efficiently treat with InBrace. And as we continue to go forward with this webinar series in the months to come, we'll be showing more and more cases that are more difficult or complex. We can go over into other topics such as finishing, which I know is a popular topic. So all of that will be coming in the future, but this series in particular was to set kind of a good foundation for everyone. So I always like to talk about the nuances of orthodontic treatment. I always believe, and we believe that most cases in orthodontic treatment, they all follow the same standard orthodontic biomechanics and principles. So really just the difference is what modality you end up choosing. So about 90% of orthodontics is the same, and the last 10% is just really that difference in modality that you're choosing. And then each modality has its own nuances that you kind of have to learn and master as an orthodontist to make it so that you're predictably and efficiently treating your cases. So I always think about traditional braces and how much nuances there are to it. And that's why we were in residency for 2 to 3 years. And we had a faculty looking over our shoulder at every appointment. And there's so many different types of bracket prescriptions, arch wire sequences, whether you repo, switch, flip brackets, what auxiliaries you use. There's so many different auxiliaries you can add to traditional braces, how you approach wire bending. So, I mean, there's just so many different nuances. And that's why people always say, this is what works in my hand, because those are the nuances they found have worked for them. Same thing with aligners. The gold standard for aligner courses are, one that takes 16 weeks, 18 weeks, 40 hours long. The AAO has, an entire column set for just aligner lectures. So, aligners have a lot of nuances to it. You have to understand overcorrection, the attachment design, your staging. How do you deal with cases that are not tracking properly? How do you deal with compliance? So there's a lot of nuances to aligners too, to really predictably and efficiently treat with it. And so InBrace is no different than the two of them. If anything, I would say that there's even less nuance to them once you actually kind of learn the few nuances to InBrace that there are. A lot of what with traditional braces and clear aligners can be applied to InBrace. And you'll find that in this webinar, there's really only a few nuances to the smile design. I would say there's 2 main ones, and the rest of them are essentially the same as what you would already do with traditional braces and clear aligners. So last week, again, we went over the clinical approach. This week, we're going over smile design. Next week, we're going to kind of touch on the clinical technique. I would say those are the 3 main components in any orthodontic treatment, that you have to do proper diagnosis and treatment planning with the smile design with InBrace. You need to have good clinical decision making. So as you see patients appointment by appointment, you're making good clinical decision and adjustments. And then you also have to deliver everything with a good hands-on technique so that you don't have a lot of bond failure and things like that. So with the smile design, I would say the general overview of your smile design approach, as well as just InBrace treatment in general, is step 1, you set your patient-specific ideal setup. So that's your predictable and achievable treatment goals. And that's what you discuss with the patient and what their chief complaint is and where they're maybe willing to compromise. A lot of adult patients may not want to go through extractions or surgery or even rubber band wear. And so you may be compromising on something. So that's why we like to call it the patient-specific ideal setup, because you're going to what the patient wants as well as what you as the provider can compromise on. Step 2 would be after you set your patient-specific ideal setup, you would layer on the overcorrection. So this is creating the proper force system. And then final step is after you've created the proper setup, then you need to do also the proper clinical approach, which is what we discussed again in the last webinar last week. So with InBrace overcorrection, I would like to just remind everyone that overcorrection is a standard thing in orthodontics. I mean, in traditional braces, it's very commonly used with like a reverse curved V arch wire, intrusion arches. Even your bracket prescriptions have a lot of overcorrection built into them compared to what like the Andrews or Reed would be. So MBT has 17 degrees of torque built into the upper centrals, for example. So you have to think about that sometimes and think about what you're doing with your traditional bracket prescriptions and apply that into your InBrace smile design, which we'll be going over. Same thing with the clear aligners. Clear aligners, very common to build in this reverse curved V into your ClinCheck. So overcorrection is just a very common thing, I would say, in orthodontics. And then the 2 major reasons why we're using overcorrection, one is to increase the force level of specific tooth movements, and the other is to counteract any unfavorable side effects of planned mechanics and tooth movements. So generally the approach that I take when thinking about overcorrection is I'm looking at every tooth movement that I'm trying to achieve, the biomechanics required to get them. I'm looking at, okay, are any of the movements going to cause, or any like the external forces like elastics going to cause favorable or unfavorable side effects? And then you'll add an overcorrection as needed to either increase the force level and or counteract any unfavorable side effects. A lot of providers, when I kind of go over all of this with them, they get really held up in how much overcorrection do I add? Do I add 5 degrees or do I add 10 degrees or add 15? You know, I always tell people you don't have to be too concerned about that. The most important thing is you're adding the overcorrection in the proper direction. We'll talk about, you know, we'll talk about where some people kind of miss going in the right direction, but as long as you're going in the proper direction, I don't really care if you did 3 degrees or 5 degrees or 7 degrees, but at least you're going in the proper direction. Any minor details in that, you know, with a couple of degrees, that's very easily to fix with digital enhancement. But, you know, if you're going in the wrong direction, then you're just going in the wrong direction. So when you're co-designing the InBraceSmile Design with our InBraceSmile Design team, we do add in some InBrace overcorrections for you, particularly the rotation tip side effect, which we'll be going over later in this webinar. So I would say one common, pitfall that some people will do is they will actually take out the overcorrection that we added in. So again, we recommend leaving the overcorrection that we add in for you, or if anything, you may want to adjust and increase it. But we will always inform you. So just know that any overcorrection we add, we will add that in for you. But ultimately, I always let every provider know, like, you know, you're the orthodontist that's responsible for this patient. So you're responsible for reviewing, adjusting, and approving the InBraceSmile Design. So I always think it's really important for every provider to have an understanding, at least, of how the InBrace overcorrections work. So, you know, again, we have this 3 steps: usually patient-specific ideal setup, add overcorrection, clinical approach. And so to make this more systematic in terms of how you approach your smile design, I kind of took these 3 steps and broke it down into kind of broke it down under like 5 major steps, which is general diagnosis and treatment planning, which is vertical AP transverse, arch length discrepancy, so figure out your crowding and spacing, and then finally individual tooth assessment. And so we'll be going through each one of these 5 steps. This is all detailed also in the InBraceSmile Design reference guide that I mentioned earlier, that's going to be released in the near future. So starting with the vertical, after you've set like what you want your patient-specific ideal setup, so we'll say for this scenario, we're going to say 2 millimeters is our ideal overbite that we generally try to achieve. First thing you'll do is you measure your initial overbite. You will then estimate the effect of crowding, spacing, and IPR on the overbite. I would say this is the major step that most people miss doing when I review cases with them. Step 3 is you request for any necessary overcorrection. And then step 4 would be support that vertical overcorrection with the proper clinical approach. So to measure the initial overbite, super simple. Turn on the grid function, turn on the transparency. Transparency is in the top right corner. Once you turn on the transparency, you can zoom in. You can see the size of the grid at the top middle. So right now it's 1 millimeter. So you just simply count the squares. And in this case, you would have about a 4 millimeter overbite. So this step takes me, 5-10 seconds to do. The next thing I do is I look at the amount of crowding and spacing, and I estimate how much of that's going to cause for bite opening or closing. Again, something like this you can estimate your crowding and spacing fairly quickly and get an idea within 10-15 seconds. So just remember general rules with how it affects the overbite, which is when you have relative intrusion by unraveling or crowding, you're going to get some intrusion, and then when you have closing of spaces, you're going to get some relative extrusion. So with crowding, that's generally going to be unfavorable for open bites because it'll open up bite more, but it'll be favorable by helping level and open up the deep bite. And with spacing, it's favorable for open bites, but unfavorable for deep bites. So when I was working on this with Dr. Scott Schwartz, he kind of really challenged me to kind of make this, I think, a little bit more systematic. And he was saying, okay, let's try to come up with a good saying for how we can remember this really easily. So we came up with a saying, instead of it's as easy as 1, 2, 3, it's as easy as 2, 4, 6. So if you have between 2 to 4 millimeters of crowding or spacing, that will roughly translate our estimate out to about 1 millimeter of bite opening or deepening. Between 4 to 6 millimeters of crowding and spacing, you'll get about 2 millimeters of bite opening or deepening. And greater than 6 millimeters of crowding, you're going to get about 3 millimeters of bite opening or deepening. So you could also just see it as mild, moderate, severe crowding or spacing. You get 1, 2, 3 bite opening, deepening. And then essentially after that, it becomes a calculation where you know your initial overbite, you know about how much bite opening or deepening you're going to get. You combine those together, you get whatever your resulting overbite is. And then based on your resulting overbite, you'll overcorrect accordingly. So if your resulting overbite is a deep bite, then you're going to overcorrect towards an open bite. And usually we say roughly about a 2 millimeter limit because we just want to keep things roughly in a controlled region of overcorrection. And so if you have an overbite, that resulting overbite that's an open bite, your maximum overbite overcorrection would be towards a deep bite, which would be about 4 millimeters. So about 2 millimeters in either direction if 2 millimeters is your ideal. So looking at an example, this is a 6 millimeter overbite. So again, turned on the grid, turned on the transparency in the upper right, scrolled in, zoomed in, and then you have about 6 millimeters when you count the boxes. So a lot of people look at this and they go directly to, okay, I have a deep bite, I'm going to overcorrect an open bite. I would say that's super common for a lot of people to do. But if you were to go straight to that rationale, you would actually be overcorrecting in the wrong direction. And again, the most important thing to me is you overcorrect in the right direction. And so the way to see that would be in step 2, you would look at the crowding and spacing. So when I look at the lower, I think, okay, that's probably severe crowding. That's probably more than 6 millimeters of crowding. So we'll say that's about 3 millimeters of bite opening. Because again, it's not as easy as 1, 2, 3, it's as easy as 2, 4, 6, and we're over 6 millimeters. On the upper, it's more moderate crowding. So, I would estimate that as between 4 to 6 millimeters of crowding. So in that case, you have about 2 millimeters of bite opening. So if you have about 5 millimeters of bite opening between the upper and the lower arch, you add that to your initial overbite of 6 millimeters. That means you're going to have a resulting overbite about 1 millimeter, meaning you're actually closer to an open bite tendency rather than a deep bite. So with an open bite tendency, you actually want to overcorrect towards a deep bite, which is why I'm saying if you were overcorrect automatically to an open bite because you said, oh, a deep bite case, then you'd be overcorrecting in the wrong direction. You'd be even opening up further. Because actually what happened in this case is we ended up with a resulting overbite of 0 millimeters. So again, our estimate was pretty close. So based on the actual resulting overbite, you actually probably should have overcorrected this case to about a 4 millimeter deep bite. So actually maintaining some of the initial deep bite that it started with. So after you know what you want to set your overbite to, then you look at which teeth should I extrude or intrude. So you're looking at your general clinical indicators. So your maxillary incisal display, your curvus B, where the crowding or spacing presents. So for example, in this case here, most of the crowding is presenting in the lower. And this patient could potentially benefit from some maxillary incisal display. It's not a full animated smile in his case, but he could benefit from a little bit more incisal display. So we're going to overcorrect to a 3.5 millimeter overbite by extruding upper 3 to 3 by 0.5 millimeter past the ideal and lower 3 to 3 by 1 millimeter past the ideal. And so, again, I always emphasize just overcorrecting the right direction. Like, you could have overcorrected this to a 3 millimeter overbite, 3.5 millimeter overbite, 4 millimeter overbite. Doesn't really matter as long as you're going properly in that proper right direction. And so in this case, as we're overcorrecting towards a deep bite, that's the most important thing. And I always, again, let everyone know, like, you want to specify which teeth you want to extrude, because if not, you're leaving it up to the smile designer. And, our smile designers are well-trained, but then again, they're still not orthodontists, and they can't read your mind on exactly which teeth you want to extrude or intrude. The other thing I recommend is that you want to make sure your tooth movements are going in harmony with whatever your planned clinical mechanics are. What I mean by that is, say, for example, you're running vertical elastics because you have an open bite. So in that case, you want to make sure that you're planned your smart wires to close the bite. So, maybe you're going to just, you wouldn't want to leave your smart wire in an open bite position, because as you try to run your elastics, if the smart wire is trying to keep the bite open, then it's not going to close, or it's just going to be fighting against each other. So again, I always think about what are my smart wires doing? What elastics am I going to plan? And I just make sure that those two are going to work together rather than fight against each other. And then the clinical approach that you would take with vertical to assist anything with your vertical correction would be either just bite turbos or elastics. So we do recommend anterior bite turbos for deep bite cases, posterior bite turbos for open bite cases, anterior vertical elastics for open bite cases, and posterior vertical elastics for deep bite cases. So we do recommend being a little bit more deliberate with your bite turbo placement. With posterior bite turbos, which we find a lot of providers just tend to go straight to the posterior bite turbos, because that's what they traditionally do with traditional braces. But we recommend, again, for cases that are deep bite, use the flexible anterior bite turbos. It's actually very easy to place them. They're even easier to take off than posterior bite turbos because they just peel off. And then we have a really great video on the knowledge base on how to apply these. With elastic wear, with vertical elastics, I normally recommend keeping it a little bit on the lighter side. Just keep in mind that we don't have a rigid, straight stainless steel arch wire when you're running your vertical elastics to close an open bite. You have a light tie wire with loops in between it that doesn't hold that vertical as well as a straight stainless steel arch wire would. So you don't want to overpower by running really strong elastics on a single tooth, because that'll really just extrude that tooth and not propagate it down. So if you're going to run elastics, run them light. I find that most of my cases with open bites, I run light elastics in Smart Wire 2, and then they close really nicely and predictably, even if they're just wearing it at nighttime. So in this case here, like I do a lot of the vertical elastics shown on the bottom, where I run it from the IP loop between the upper ones down to the lower twos. And I talked about this actually a lot in the last webinar, and actually even talked about different examples and different and how to approach the vertical elastic wear. So all of this is discussed in the reference guide. So everything I just went over is in this reference guide. And everything that we just went over with the vertical, it's really no different than traditional braces or aligners. I would say you essentially approach them the exact same way as traditional braces or aligners, just kind of reminding you how you would do that with InBrace. So with the AP, similarly, we follow a similar approach where step one, you determine your amount of AP correction desires, you do your diagnosis and treatment planning. You determine if the side effects of the inner-arch elastics will be favorable or unfavorable. And then you request for the necessary overcorrection past the ideal to counteract any unfavorable side effects. And then you just support it with the proper clinical approach. So with general limits for AP correction, we follow essentially the same thing. It's not as easy as 1, 2, 3, but it's as easy as 2, 4, 6. And then these are just general limits. You don't have to follow necessarily these exact limits, but I would say if you follow these, they probably will work almost every single time. It's very predictable to correct a 2 millimeter, about a quarter cusp class 2, class 3 with class 2 or class 3 elastics. An end on class 2 or class 3, about 4 millimeters. It's a little bit more predictable to approach that with a distalization, extractions, or just accepting it. And then if you're at 6 millimeters or more, I'd say it's more predictable, full cusp or closer to a full cusp. Extractions, orthodontic surgery, or just accepting it would be much more predictable. Can you push these limits? For sure. But, as you push the limits, you're going to get less and less predictable AP correction. So with AP correction, you're mainly trying to counteract the side effects that you're going to get from the external forces you're applying for the AP correction. And these are very well documented. So whether it's class 2 or class 3 elastics, just think through what are the side effects I'm going to get by adding these external elastics, these external forces. And then you have to add overcorrection accordingly. And a lot of times these overcorrections are with traditional braces are kind of already built in to your bracket prescriptions because they're so common. But you have to kind of build that in with the Smart Wire. So for example, like the most common one I would say is like palatal root torque on your upper 2 to 2 with class 2 elastic wear, because with class 2 elastics, you get some torque loss on your upper anterior teeth. So adding some palatal root torque there to kind of prevent that is very common. You also get commonly distal crown, mesial crown tip as a side effect on your molars when you run class 2 or class 3 elastics. So adding that distal crown tip to prevent that also, I would say, is a good practice. All these other ones are still applicable to add. You add them just when needed. It just really depends on how the malocclusion presents itself. So looking at this class 2 case, about 2 millimeters of class 2 correction is needed. It's about a quarter cut class 2. And so general side effects that we'd be watching out for if we're running this from upper 3 to lower 6 would be, the upper 2 to 2 is slightly proclined. So it's actually a little bit favorable to get some torque loss here. However, you also have some upper spaces. So, the combination of closing upper spaces and running class 2 elastics may be a little bit too much torque loss. So adding some torque overcorrection here, I think would be applicable. And then the lower right 6 actually starts with slightly excessive mesial crown tip. So the side effects are going to be unfavorable if you have more mesial crown tip. Now, this case is shown here now without any overcorrection. So what overcorrection that would be applicable here would be add some palatal root torque to upper 2 to 2. So again, don't have to be exact with the exact numbering. Like here I'm showing 8 degrees and 5 degrees on the upper ones and twos. You could have done like 10 degrees and 7 degrees. As long as, again, you're adding in the palatal root torque, that's the most important thing. Sometimes, well, I would say in theory, you should add more to your upper ones than your upper twos. Just for the same reasons why there's more on the upper ones versus the upper twos for like MBT prescription or Roth prescription. You know, the anchor for your torque expression is the upper canines for your upper laterals, which you have a really good anchor on that upper canines, but for the upper centrals, it's much weaker because it's further away from the canines, and then the laterals are not as good as an anchor. And then we also here recommending add 5 degrees of distal crown tip to that lower right 6. So this case was actually approved without any overcorrection. So it's good to see what happens when you don't add overcorrection. So comparing this now, when the patient came back 10 months later for a DE scan, you can see that the upper 2-to-2 torque is fairly normal. However, you are going to need to run some more class 2 correction. You can still see the canines are fairly class 2. So, you are expecting to have more torque loss. So some torque overcorrection, I think, would have been beneficial based on how the patient came back. As well as the lower right 6, you can see how much it tipped forward compared to the initial. So that's why that definitely could have benefited from some distal crown tip. The other thing you can see is that, the spaces are closed, and even after wearing the class 2 elastics for a decent number of time within that 10 months, there's still a significant class 2 in the canine region. So when you are approaching this clinically, the strength that you would consider for your elastics are light for SmartWire 1, medium for SmartWire 2, heavy for SmartWire 3. And these are the type of cases, especially when they're spacing, that you may want to consider starting with light elastics in SmartWire 1 to increase your anchorage, because you always have to remember that with InBrace, the spaces will close starting from day 1, because the IP loops are going to be activated to close the spaces. So the spaces are generally going to close reciprocally. And in a case like this, where you have a class 2, you actually want to increase your upper molar anchorage. So one way to do this very easily is to add some class 2 elastics early on. So in this case, what I would do is I would add class 2 elastics from upper 4 to lower 6, just to hold that upper 4 back, and then make it so that the 3-to-3 will come back to help close that space. So when you're doing this, though, you have to think about what overcorrections you might need to add to that upper 4. Because now that the upper 4, it's actually more of a vertical component to the 4s now that you're doing a short class 2 elastic. So you're going to get some more extrusion side effect on that 4. And when you do that, you might actually end up opening the bite up more, because you're going to get a premature interference on that posterior, on the upper right 4. So here you might actually also consider adding some intrusion overcorrection on the upper right 4. Somewhere between 0.2 to 0.5. So commonly I'll add about 0.3 millimeters here. And so again, this is pretty standard. It's the same side effects, whether it's traditional braces or aligners, but you just have to think that, again, you're doing this on a lighter SmartWire. So you have to, again, keep lighter elastics and add some overcorrection in to counteract the side effects that you're expecting here. Okay, going into transverse now. So transverse, just in general with orthodontics, you have 3 options. You either perform some dental expansion, or you perform some skeletal expansion. Generally with InBrace, I would recommend try to maintain your transverse dimension. I think that's just by far the most predictable and efficient option. The least amount of movement you need to do, the more predictable and efficient your treatment will go. If you do need to perform dental expansion, about 1 to 2 millimeters per side is achievable. You would just need to add some overcorrection, about 3 millimeters of expansion past the existing arch form, and then add some buccal root torque if needed. It just depends on how your existing malocclusion presents itself. But adding some buccal root torque to kind of prevent the tipping would be good. And then you may also need to go to SmartWire 3. SmartWire 3 is the largest SmartWire that we use, and that will help express more of the dental expansion, as well as using cross elastics if needed. Or you can use an auxiliary expander as well. So the cross elastics can actually be ran from the IP loops. So when doing your dental expansion, you should look at what the pre-existing malocclusion starts with. So in this example here, the upper 3s and the upper 7s are buccally displaced. So that'll actually serve as very good anchors to favorably expand the upper 4 to 6. So as the upper 4 to 6 comes out, upper 3 to 7 come in. And then you actually don't really need overcorrection in a case like that, because these movements are very favorable. So in this case, I would just go to SmartWire 2 and wouldn't add any overcorrection. I would expect it to work out well. Now, if you needed to do a full arch expansion, so say in this case, upper 3 to 7 now all needs to expand because you have some tight buckle overjet. Here is where I would say, okay, let's overcorrect both sides by 3 millimeters. Let's add about 10 degrees of buckle root torque on the upper 6s and 7s. Let's add about 5 degrees on the upper 4s and 5s. And we're going to go up to upper small bore 3, let that express for at least 8-10 weeks. And then let's see if we need to run some cross elastics as well. Last option is to do some skeletal expansion. In this case, you would use an auxiliary expander. Could be used before or during treatment. And if you're going to do it during treatment, just make sure to plan the smart wire to work in harmony with the planned expansion. Again, this is where I'm saying, if you're going to plan expansion, then you have to also plan the expansion in the smart wire. If you don't plan expansion in the smart wire, it's kind of fighting what the expander is doing. So again, this is all covered in the reference guide. And then looking at the arch length discrepancy, the main area I'm going to focus on arch length discrepancy in this webinar is mainly on how do you deal with spacing. So with spacing, whenever you have your closing spaces, you can have some tip and torque side effects. And then you're going to generally want to add tip or torque overcorrection to counteract any unfavorable side effects of tip and torque. So an easy way to estimate the tip side effect per tooth, so like the crowns dumping into the space, would be with this saying, tip can be refined with 369. So what that means is if you have about 1 millimeter of space closure, you're going to get about 3 degrees of tip side effect per tooth. If you have 2 millimeters of space closure, you're going to have about 6 degrees of tip side effect per tooth. And if you have 3 millimeters of space closure, you're going to have about 9 degrees of tip side effect per tooth. So again, tip can be refined with 369. So once you know your tip side effect per tooth, then you can look at what your initial angulation is, and then you just add root tip overcorrection accordingly based on whatever your resulting angulation is. So if you look at this case here, you have a 2 millimeter space. So again, tip can be refined with 369. 2 millimeters corresponds to 6 degrees of tip side effect per tooth. So, and you start with initial angulation and inclination. So in this case, you're going to have about 6 degrees of distal root tip side effect per tooth, because the crowns are going to tip into the space. So you just add the opposite. So you add 6 degrees of mesial root tip overcorrection to both upper ones. And then to prevent any torque loss, you just add some palatal root torque to upper 2 to 2. So like around 5, somewhere between 5 to 10 degrees is generally reasonable. This is a 2 millimeter space, so about 5 degrees should be about reasonable. Let's look at another case. So this is a 1 millimeter space. So with 1 millimeter, tip can be refined with 369. You're going to have about 3 degrees of distal root tip side effect per tooth. However, in this case, you actually have excessive mesial root tip. So the roots are kind of in the right spot to begin with. You have flared upper incisors. So you don't really need overcorrection because the side effect is going to be favorable. You're going to end up essentially in the right spot. And then any space side effect of torque loss from the space closure is actually a good thing because the case started with flared upper incisors. Now, when you have larger spaces, you should consider staging the space closure. So, the IP loop essentially acts like a closing loop when there's spaces. And with a traditional closing loop, if someone ever told you, let's activate a closing loop 8 millimeters to close an extraction space in one go, you would never do that because you're going to cause a ton of dumping into the space. Usually you stage it where you activate 1, 2, 3 millimeters per time per appointment. So same thing here. Our recommendation is don't activate an IP loop more than 3 millimeters for space closure. So you can close up to 3 millimeters with your smaller 1 and smaller 2. Then you can submit for a digital enhancement after those have expressed to close the remaining spaces. So you would actually purposely leave some space in your initial smile design. So for example, if you have a space between 3 to 6 millimeters, our general recommendation is close about half the space. So if you had 4 millimeter space, you would close about 2 millimeters in your initial smile design and 2 millimeters in your digital enhancement. Usually I recommend just evening it out. I think that just logically makes more sense than over activating in the beginning. So technically in a 4 millimeter space, you could do 3 millimeters in your first smile design and then 1 millimeter in your DE. But I think it just makes logical more sense to even it out and just have it. So if you were doing, say, like an extraction space, you had like an 8 millimeter extraction space or like a 7 millimeter extraction space. Instead of doing 3 millimeters, 3 millimeters, 1 millimeter in your 3 stages, I would just even it out and do about 2.5 in each stage. So after you stage the space closure, you're still causing space closure. So you're still going to have some tip and torque side effect for that amount of staged space closure. So then you add the tip and torque as needed. So looking at this diastema, this is a 4 millimeter diastema. So based on what we just discussed, you would close only about half the space between the upper ones. And then again, you're still going to have that tip side effect. So if we're closing half the space, we're closing about 2 millimeters. So tip can be refined with 369. So 2 millimeters of space closure is going to be about 6 degrees of tip side effect per tooth. So we're going to add about 6 degrees of mesial root tip past the ideal to both upper one to counteract the 6 degrees of side effect that we're expecting per tooth. And then we'll also add about 5 degrees of hollow root torque to upper 2 to 2. Now you can notice that I have some additional text in teal here, where it says where the distal incisal edge is 0.5 millimeter more extruded than the mesial incisal edge of the upper twos. So this is not talking about the vertical positioning of the tooth. So anytime you add tip to any tooth, you're kind of also end up playing with the vertical positioning, how it vertically places relative to its adjacent teeth. So this is actually the case, how the case was approved. So you see the amount of root tip applied was appropriate, but the vertical positioning is a little strange when you look at this. So, and this is what happened about 10 months later. So you actually ended up with a reverse smile arc. And then you can see that the upper laterals are actually more extruded than the distal incisal edge of the upper ones. So when we kind of look more into this, and think about what's happening here. So what's happening is the upper centrals want to dump into the space. When it dumps into the space, the mesial incisal edge are actually kind of intruding into the space. And then if you look at the approved small design now on the right-hand side, the distal incisal edges are intruding relative to the upper lateral. So you have intrusion based on the side effect from the crowns dumping into the space. And you also have intrusion relative from the 1 and the 2. So the net overall effect you get is just a general intrusion of your upper ones. And so what you should do instead is you want to make sure that your upper 1-2 transition is ideal. So simply what all I'm saying here, where the distal incisal edge is 0.5 millimeters more extruded than the mesial incisal edges of the upper twos, is that you're placing the relationship between the 1 and the 2 at what you consider ideal. So many consider ideal to be about 0.5 millimeter more extruded than the lateral. So that's what we had written here, but that's essentially whatever you consider your ideal to be. Because you don't want to be like this again, where the approved small design has the upper centrals more intruded than the laterals, because that's what's going to cause, again, like a reverse smile arc. With generalized spacing, you need to think about how the IP loops are closing spaces. Essentially, the way they're closing spaces is they're being stretched to engage into the malocclusion, and it's going to close to go back to how it's programmed. Now, if you're having that stretching and the force is coming from every single side because it's generalized spacing, it actually will counteract that tipping force that you're going to get with the space closure. So that all negates, and you end up essentially with just retraction. Now, when you have retraction, you're still going to have torque loss. So you still need to add torque over correction. But generally, when you have like fairly even generalized spacing, most of the time that'll actually counteract and stuff. And a lot of times overcorrection for tip is not needed. And then here, all of that I just discussed is detailed out in the reference guide. So the last step, and the step that I would say actually kind of goes over the main nuances of InBrace, is in the individual tooth assessment. I would say everything kind of above this section is pretty standard within orthodontics. I don't think it's anything surprising to anyone. So there's essentially kind of 5 steps, I think, to the last step on individual tooth assessment. First one is just remove any tooth movements that were added that may have been unwanted. It just really depends on how detailed your prescription is, on how accurate the small designers will be able to replicate what you're looking for. So there are going to be times where the small designers may add in movements that were not wanted by you, or may. So whenever you see that, just remove it. So if I ever see a movement, say like a single tooth torque, that torque is not necessary, and a lot of times when you add torque to a tooth, it causes side effects. So anytime I see that, I would just remove it. Or if there's maybe a tip that wasn't necessary, I just say, please remove the planned torque or the planned tip or whatever planned movement that I didn't want. Next thing I do is I just make sure everything's ideal, detailed how I want it. So I'll go through and just add whatever rotations, leveling, root tip that I feel is necessary to make it more ideal. The third step is add any tip overcorrection to increase the force levels, particularly, so like in this case here with the lower left 4, it starts with excessive mesial root tip, you need distal root tip. So adding about 5 degrees of distal root tip past the ideal will help this express a little bit more predictably. So these are all pretty straightforward, I would say. The last 2 steps of this of the individual tooth assessments, the upper central incisor rotation tip side effects and additional virtual power chain, these are the 2 major nuances of small design, of the InBrace small design. So it's really important to understand these 2 components and make sure to add these in when applicable. So with the upper central incisor rotation tip side effect, we know that in this scenario, if you do an upper right 1 mesial out rotation, we're going to get a distal root tip side effect. And so the easiest way to understand and see why this happens is you split the tooth in half, and you remember general relative extrusion and intrusion rules, where when you bring a tooth out labially, you're going to get relative intrusion, and you bring a tooth lingually, and you're going to get relative extrusion. And if you do that to each side of the tooth as you get a rotation, the mesial is coming out in this case, you're going to get relative intrusion on the mesial, distal is coming in, you're going to get relative extrusion on the distal. And the net effect of that is a root tip. So you can always work that out in your head. It's a fairly logical progression, or you just remember mesial out, distal in rotation results in distal root tip, distal out, mesial in rotation results in mesial root tip. A lot of people remember it within the in. So distal in rotation, distal root tip side effect, mesial in rotation, mesial root tip side effects. So when we look at a case example for this, upper ones in this case require a mesial out rotation. However, and then if you look at the initial angulation on the bottom left, starts in a fairly ideal angulation. No overcorrection was placed in this one, but you can see again, mesial out rotation is going to be planned. And if you look at the top right, the mesial out rotation was achieved. So when you look at the top view, things look great. But then when you look in the bottom right image, now we have distal root tip, the distal root tip side effect that we expected because mesial came out relative intruded, distal came in relative extruded. You got a net distal root tip side effect. And in this case, it's unfavorable and that unfavorable movement expressed. So what you should have done in this case is we should have added some mesial root tip overcorrection. So if you add the mesial root tip overcorrection, that counteracts the distal root tip side effect, and you end up roughly in the ideal place. So this unfavorable, it's not always unfavorable. Actually, many times it's favorable. So in this scenario here, both upper centrals start with excessive mesial root tip. If you were doing this with aligners, for example, you would add a pretty good amount of distal root tip overcorrection to fix the tip. But in this case, we added actually no overcorrection, even though they're very excessively tipped. And within 3 months, actually the tip resolved very easily along with the rotation overcorrection. And the reason why is the rotation tip side effect, because it's favorable. So if we kind of think about this again, upper ones both require mesial out rotation. Mesial is going to relatively intrude, distal is going to relatively extrude. It's going to cause a distal root tip side effect. And upper left one actually has a larger rotation than upper right one. It also needs more distal root tip. So it all kind of worked out favorably because of the distal root tip side effect. So in actually many cases, it's actually a favorable movement. So that's why it's important to understand whether it's going to be unfavorable or favorable. And this is where, again, I always talk about, most important thing is overcorrecting the right direction, not really necessarily the amount. But if you did need to estimate it, then we can use the exact same saying as we use for space closure, because we're dealing with tip, and its tip can be refined with 369. So if you perceive it as a mild rotation, most likely it's going to be about 3 degrees of a tip side effect. Moderate rotation is going to be about 6 degrees of tip side effect, and severe rotation is going to be about 9 degrees of tip side effect. So after you know your tip side effect, and you look at what is your rough initial angulation, you combine your initial angulation, your original tip, with the tip side effect, you get your resulting angulation, and then you just add root tip overcorrection to counteract it accordingly. So for this example here, we're starting with 3 degrees of distal root tip. We can see on the bottom it's going to be a mesial out rotation on the upper right one. So when you do that, and we will say this is a mild mesial out rotation. So it's going to be 3 degrees because tip can be refined with 369. So now adding those together, because you started with distal root tip, you're adding more distal root tip in the side effect, you're going to end up with a 6 degree distal root tip result, like a resulting angulation of 6 degrees of distal root tip. So you simply just add the opposite. You're going to add 6 degrees of mesial root tip overcorrection into the smile design, and that will roughly get you to ideal when you let the smart wire express. Now, I mentioned this earlier, but whenever you add in tip, you have to also consider the vertical position. So actually, there is a 4th step to the upper central incisor rotation tip side effect, which is after you figure out how much tip to add in, then you adjust the vertical position. So the 2 vertical positions that most providers I get confused on and which one to go with is either your upper ones are level or your upper right 1, 2 has the proper vertical discrepancy. So the way to kind of work this out is usually the relative intrusion side will dominate because normally there's crowding and normally the tooth is going to come out more to match the arch form. So relative intrusion generally dominates. And so if relative intrusion is dominating, the main thing you're trying to counteract is the relative intrusion side. So that means you want the side that's going to have relative intrusion to be extruded past the ideal. So usually we'll just place the side that has, so if you kind of played that out and you let the relative intrusion side play out, you can see that option 2 is the better one, where you started with the upper 1-2 discrepancy in the proper place. And so that's why we would also add this second part of the statement. You add 6 degrees of mesial roots of overcorrection past the ideal to upper right 1, where the distal incisal edge is 0.5 millimeter more extruded than the mesial incisal edge of the upper right 2. So essentially, you're just placing, again, the upper right 1 distal incisal edge in its ideal location relative to the 2, what you consider the ideal location. And so the easiest way that I remember this is whatever side is rotating in or lingually, you place that side in the ideal vertical position. And then that makes the other side extrude past the ideal. And that side is the relative intrusion side that will counteract and end up roughly level. Okay, so the next one is the virtual power chain. So this is the last nuance of InBrace, smile design. So the universal virtual power chain actually is standard in orthodontics. This is to counteract any segmentation issue. So we add in 0.2 millimeters as the general default to every single case. This is why sometimes you'll see the arches are virtually shortening, meaning we're overlapping each contact, and that makes the arch shorten. That actually doesn't express clinically. So we actually will move all the posterior teeth forward. That way you can maintain and see the anterior arch form and changes very easily. So don't be alarmed if you see the 7s moving when there's no brackets. Don't be alarmed if you get an implant that an implant is moving. As long as it's just a mesial distal movement for the power chain, all we're really doing is making the IP loop a little bit narrower, because you're shortening the inner bracket distance, which is what we use to create the width of the IP loop. And that will add a little bit more mesial distal force to make sure your contacts stay tight. Now, sometimes you need to add additional virtual power chain, which is increasing the force of the closing loop effect. And so we do this to either prevent spaces from opening up or to make sure that small spaces stay closed, or to close small spaces that are residual. And this is pretty similar to the concept of fake IPR that many people use in clear aligners, which is to increase the force by adding a little bit more interproximal collision. One of the benefits of InBrace over using fake IPR, so using additional virtual power chain, is you don't have to remember not to do it. Because with fake IPR, I hear it all the time. I've seen it happen where someone in the office didn't know it was fake, and they ended up doing the IPR. So there's a few reasons why you may get spaces forming. This is standard in orthodontics when patients come back to me all the time. Traditional braces, as the teeth have derotated, a space forms. But traditional braces, then you have braces covering it, so patients don't really mind as much. With aligners, you have plastic covering any space that opens up, so again, they don't mind as much. But with InBrace, with us being behind the teeth, you can't see it. If you do have a space open up, patients do tend to notice that, particularly if it's between the upper centrals or upper 2 to 2. So the main one is the distal out rotation that causes the space to form. So the way to visualize that is keep in mind whether it's Gen 1 or Gen 2, we make the smart wire off of the planned bracket position. And then, so you get a width based on your ideal. And then you're going to engage that wide IP loop into the malocclusion by compressing it into the malocclusion. And that will actually cause an open coil spring effect because it wants to return to its wider IP loop shape. And then that generally will cause the space to open. Now, usually if you let this keep going for a while, because again, all movements happen in all 6 degrees of freedom, but that doesn't mean all of them happen at once. Certain movements happen before the other. So usually the first thing that happens is the open coil spring effect that opens up the space. We often will see if you let it go, it may close the space as it keeps going because it's going to finish the rotation that's planned to close the space. It doesn't always happen though. So I always recommend to be safe, I would just say you want to prevent that space from forming. Even you want the rotation to occur without a space forming generally, especially between the upper centrals. So the way to do this is you add some additional virtual power chain. So you overlap the interproximal context a little bit more, so you can make that IP loop narrower to add more closing loop strength. So the way to see this or visualize is you have to imagine where the brackets are and are the brackets moving further apart by that distal out rotation? And if they are, then you should be adding additional virtual power chain. So in the initial submission, I always add it between the upper ones and between upper 1 and 2. So upper 2 to 2. If I get spaces anywhere else because of this reason, usually I just tell the patients, this is normal in orthodontics to have some spaces opening as you're unraveling crowding. And all of that will be fixed fairly easily in digital enhancement. But I'm always trying to prevent a space opening between the upper 2 to 2 in particular. Okay, so last thing to go over now is the digital enhancement. With digital enhancement, generally recommend a less is more approach. It's just general philosophy, where with traditional braces, normally when you do detailing, you don't detail it bend every single tooth. You detail bend just the teeth that you need to adjust. The less teeth you detail, the more predictable it's going to be, because every detail bend you do creates a reactionary force that makes a little bit more uncertainty into your equation. So similarly with digital enhancement smile design, I really just view this as detail bends when you're doing your final detailing. So an example, a case like this on the bottom, we're only adding some adjustments to the upper laterals and then adding virtual power chain again to make sure that the spaces stay closed. Now, sometimes you have to submit for a digital enhancement earlier. May call it something like a mid-course enhancement. It's kind of similar to what many people know as like a mid-course correction in aligners. So for whatever reason, if something's not tracking properly, you might be changing your treatment plan. You may have to submit for a DE early. And if that's the case, you're still in your stage 1 and stage 2 goals. So you would still approach it similarly to how we just discussed, because you're not really at that finishing stage yet. One major benefit of digital enhancement is that you are able to see the bracket position now. And that allows you to check your bracket position as well as assess whether the smart wires are going to activate properly. So with bracket position, any bracket that's significantly off center while also being misaligned, you should request for the bracket to be repositioned to the center of the tooth. If any bracket is way off to one side, it doesn't tend to express the rotation as predictably. It's kind of similar to if you had a traditional bracket that was way off to the mesial or way off to the distal. Can you align the tooth? Yes, but you have to add a fairly large bend that probably has some overcorrection in it to resolve a rotation when you have the bracket way off to the mesial or way off to the distal. So same thing happens with InBrace. If we made a wire exactly for this where this lower left 2 is, it does improve the rotation quite a bit. However, that last like 10% or so doesn't quite express without overcorrection built into it. Because again, the bracket is all the way off to the distal. It's just not favorable in how the biomechanics rotate that tooth. Or the easier thing is just to reposition the bracket. You don't have to add overcorrection now into the equation, and it becomes very predictable. The second benefit is you can see the smart wire activation. So I think this is fairly important because you should be able to kind of read and see, are the wires going to move how I want them to move? And the easiest way to do it is just kind of imagine it as a straight wire. Because really the only thing that matters is that difference between each teeth and between each the wire bend. So, in the DE malocclusion compared to the DE smile design, you can see the upper lateral bracket has extruded. So that's how the wire is going to be designed. So when you insert that wire from the smile design into the malocclusion, it's going to be essentially be a step down bend for that upper right tooth. So I usually will go through, always make sure to look from the lingual view and make sure you go back and forth and check, okay, are these movements what I want them to be based on how the brackets are moving? Same thing with torque. So I always caution single tooth torque changes in digital enhancement. Normally I recommend remove any single tooth torque. It's very similar to traditional braces where with traditional braces, I tend to try to avoid wiping in single tooth torque because it tends to cause some side effects. I'd rather just step in or step out to help with any minor torque changes or to even accept the torque changes if it's not significant. So in a case like this, when you have the torque changes, root torque added to this upper right 6, you can see that vertically it's changing its position. It's causing a large vertical change. And when you have that large vertical change, you have to remember the wire is designed for the smile design. So we're designing it for the white position of the bracket. And then you have to insert it into the malocclusion, and it wants to go back to what you actually designed it to. So the IP loop is going to stretch so that you can engage into the malocclusion. Then it's going to want to express to go back to its original shape, which is going to cause intrusion because of the buccal root torque plan. So the intrusion is a side effect, a vertical side effect, but it's also going to cause a reactionary force on the 5, so a reactionary extrusive force vector. So again, you're adding just a lot of unpredictability into your system. So that's why I recommend generally to try to remove single tooth torque in digital enhancement whenever possible. You can also see the inner bracket distance change a lot more easily. I would say this is one of the most important aspects and nuance of smile design, especially in digital enhancement, prevent spaces from forming when you're in digital enhancement. Because a lot of providers have expressed they're getting spaces forming. And the reason why is this increase in inner bracket distance. So when you have an increase in inner bracket distance from when you're going from the left image to the middle image, your smile design is causing a large rotation on the small layer. Now you have a large a loop that's 6.2 millimeters in width that you're inserting into a width of 5 millimeters at the malocclusion. That's going to want to open a space up. In theory, it could resolve, but it's much better to cause the rotation without opening a space. So the way to do that is you add additional virtual power chain until the inner bracket distance is either the same or slightly less than the initial, what you started with. And so it's very easy to do this. You can go back and forth with the malocclusion and setup. You can use the less than or greater than signs, it's comma or period button to go back and forth. It takes me about 30 seconds to do this, where I just go back and forth. I look at every single contact going back and forth and say, okay, so here it's like there's the space is opening between upper 2 and 3. There's an increase in inner bracket distance. There's a residual space between the upper ones. Again, here between upper 2 and 3, I can see increase in inner bracket distance, but because of the rotation. So if I see it as a mild or minor rotation or a minor amount of increase, or I'm like, is that increasing? I can't really tell, but I think it might be. I had 0.3 millimeters of additional virtual power chain. I don't really spend too much time on it. Just think, okay, it's slightly getting bigger, or maybe it's bigger. I can't really tell. At 0.3 millimeters. If you think it's a moderate amount of increase in inner bracket distance, add about 0.5 millimeters. And if it's severe, you add about 0.7 to even more than that. And so in this case here, you can see I added 0.7 millimeters of additional virtual power chain between the upper right 2 and 3 and upper left 2 and 3. And now you can't tell that there's an increase in inner bracket distance when you look between the upper 2 and 3 when I go back and forth. It should be either the same or slightly less. And so you do this for every single contact. Between the upper ones, there was a residual space in the beginning. So because there was a residual space, I added about 0.3 millimeters of additional virtual power chain, just again, to add a little bit more space looking forth. So just a recap with digital enhancement, less is more. When you're detailing, only move the teeth that generally require detailing for greatest predictability. Remove or reduce any single tooth work that tends to cause vertical rotations, as well as rotations that you don't necessarily need because that sometimes causes space opening. Check all your bracket positions. Request for any bracket position that is off-centered and misaligned to be repositioned to the center of the tooth. We'll then provide you a single tooth IDV tray if there's space present for an IDV tray to seat. And then also just check to make sure that your SmartWire activation matches your remaining treatment goals, particularly with your additional virtual power chain, adding that enough sufficiently to prevent any spaces from opening. So all of this is detailed again in the reference guide. So you'll be seeing in the near future, we'll be updating the fundamentals of InBrace mini residency to cover everything we just went over here, plus even in more detail in the modules in the fundamentals of InBrace mini residency, as well as we have the smile design reference guide, which again, you can very easily see all of the things we just discussed on a single sheet of paper. So the nuances, the main nuances of InBraceSmile Design, add overcorrection in the proper direction. That's way more important than the exact amount. And then add overcorrection to counteract any unfavorable upper central incisor rotation tip side effects. So again, mesial out distal end rotation results in a distal root tip side effect. Distal out mesial in rotation result in a mesial root tip side effect. And again, we will generally add this in for you. So don't take it out if we add it in for you. Just see, do I need to add a little bit more or less? And then when you are doing your finishing for digital enhancement, less is more. Only move the teeth that are required for detailing when you're in that finishing stage for digital enhancement. Reposition any bracket that's off-centered on a tooth that is misaligned. And then add additional virtual power chain to prevent spaces from opening due to that increase in inner bracket distance. So for initial smile design, usually I'm just focused on upper 2 to 2. For DE smile design, when I'm finishing though, I really want to make sure that all my spaces stay closed when I'm finishing. So that's it for this webinar on digital smile design. And then next week, we're going to be going into a deep look into some different case studies. And now we can open it up for questions.
Thank you, Dr. Lee, for a very robust and thorough overview of smile designs here. So we have a few questions here. First question is, will any of these nuances that you mentioned be added in by the design team, or is it something that clinicians have to remember to do themselves?
Yeah, so the upper central incisor rotation tip side effects is being added in by the smile design team. Additional virtual power chain at this time is not, we do add the universal virtual power chain in, but the additional virtual power chain is not being added in.
Dr. Tara, I know you manage that team, so any other inputs you want to give there?
No, they will also add in the rotation tip, and then if there's any disclaimer, they'll type back within the text box or vision for you to know what's in there and what's not. So if you have any questions ever too, you can ask the design team when you're typing to them if you want to know what they put in and what they haven't. So just a heads up.
Great. We had I saw oops, that's not me. I saw Dr. Berry raise her hand. How do I is she still here? Or did she sign off?
I'm not seeing, maybe you can type the question if there's a
I
question.
think I don't see her in the attendees anymore.
She was there for a second and she raised her hand, but Dr. Berry, if you're there, you can type it in or raise your hand again if you come back. Another question here. How do we identify the bracket distance getting further apart in the initial smile design?
Yeah, so for the initial smile design, I would just say it's you're mainly just focused on upper 2 to 2. So you're just you just have to imagine essentially where the brackets are and visualize where the brackets are and if they're getting further or closer together. Usually it's the distal out rotation. So when you look at, say, for example, here, anytime you have a distal out rotation on your upper ones, the cingulums are getting further apart. So if the cingulums are getting further apart, you know that you need to add some additional virtual power chain. So same thing with the upper 2s. If there's an increase in the inner bracket distance or increase in where the cingulums are between the 1s and 2s, you can say, okay, that's going to have an increase in inner bracket distance. I need to add some additional virtual power chain.
Now, but when you actually do it, you literally just go, was it less than, greater than, and you just go back and forth, and when we toggle it, you can see it happening.
Yeah, so essentially you toggle back and forth with the less than and greater than sign. It's very easy to visualize that. So, you know, when you see when you see it with the brackets on, and say like this example here, you'll see that you can, like, between the upper 2s and 3s here, you can very clearly see that inner bracket distance is increasing. So you can see the same thing without the brackets. And you just kind of estimate, okay, it's a minor rotation, so maybe I'll do 0.3 millimeters, or it's a moderate rotation, like 0.5 millimeters, or that's a pretty severe, it looks like a pretty huge amount of distance change, but that 0.7 millimeters or even more.
Yeah. Are you using the grid for this?
You can. So in the beginning, you may want to just to kind of measure it out in your head, but you know, as you get more experience in doing it, you can very quickly identify it without having to use the grid. But in the example, like I showed here, like I did measure this one out with a grid just for accuracy purposes. But normally what I would do here is I would say, that looks pretty big. I'm going to add 0.7 millimeters or 0.8 millimeters. I get the small design back, small design 2, and say, okay, then I check it again. Okay, that might not have been enough. So I'm going to add another like 0.5 millimeters. Usually, again, most of these things are super fast to do. Every single one of the steps, I know it seems like a lot, but total time it takes me to revise a small design, because again, I only have to worry about small design overcorrection. I don't have to worry about attachments or staging or anything like that. It takes me 5 minutes or less for most cases.
So this is something I'm gonna just step in and take a big step back here. Right. We're talking about a lot here, but this is like us systematically talking about like, how do you walk? You know, and we're really going through like proprioception of it and all these little things as if we don't know how to walk. You know, the honest truth, we really take a big step back and look at everything, is that a lot of this stuff is intuitive. We already know it's orthodontist. We're just trying to break it down in a very systematic manner. But yeah, you know, once you do a few of these with the intent in mind of what we're talking about, it really becomes pretty straightforward. So if I can just take a step back here, Dr. Lee, I know you went through really a systematic approach, but what are the differences between this and what we already know at a high level, again, of these nuances that you're talking about? Because it's really just these 5 bullets, right? Yeah,
I would say the main ones: upper central and size rotation tip side effects, and then when to add additional virtual power chain to prevent spaces. So it's the tipping that you're getting in the centrals, as well as spaces that you might be getting. Those are the 2 main nuances, and we know exactly how to prevent them from happening.
Okay. So yeah, if I were to remember anything from all this, It's this slide right here. Everything else is stuff that we kind of know. We're just kind of like reviewing it as far as, overcorrections and smile designs. And again, it applies to aligners, it applies to everything else. Question coming from Dr. Wang. I heard DE wires by default come with a 0.1 millimeter virtual power chain. So is this interproximal collision in addition to the universal power chain?
Yeah, so it's in addition. So universal virtual power chain is 0.2 millimeters on every single contact. So that's why sometimes you'll actually see as a default, and when you get your cases back, all the teeth are moving. And that's just, again, to make sure your contacts stay tight if there was a segmentation issue. Because for any digital solution, whether it's aligners, InBrace, or any others, you have to cut the teeth out of the scan. And when you cut the teeth out, it's impossible to always get that perfect for any system. So that's why aligners also has virtual power chain to make sure to address any of those potential segmentation issues. Now, that's not enough to counteract the change in inner bracket distance that we get because we have the IP loops in between every single tooth. So whenever you have an increase in inner bracket distance, it has the potential, it doesn't necessarily, but has the potential of creating a space. You should add additional virtual power chain just to ensure that a space doesn't form in that area.
Now, with that being said, though, as we mature as a company and, more types of orthodontists come in. I mean, some orthodontists want to know how all the sausage is made. Some of them are like, just make the teeth straight and let me kind of react from there. Dr. Tara, can you talk about some of the new innovation we're coming out with as far as software improvements in the upcoming months that might, make things easier for folks?
Yeah, definitely. And we did just push out our spring edition of our innovation kind of newsletter. So what pertains directly to the Smile Design is the Smile Design editor. So you'll be able to go in and make some of these small tweaks and movements yourself. And that's estimated to come by June, which is awesome. And if you guys would like insights into the rest of the innovations coming down the pipeline, some of them are specialty smart wires, the iTero integration, but check out the in group. I did post yesterday the newsletter. So feel free to take a look and then feel free to ask any questions that you have too.
And I think at a high level, we're working on some intelligent force system stuff to where a lot of this overcorrection stuff is going to be handled in the background and people don't have to worry about visualizing these things. So can you talk a little bit about that?
Yeah, so we're working right now. It's in beta. So with the in-studio providers and a very small group where we're going to move some of these overcorrections behind the scenes. So the virtual power chain, the rotation tip side effect is kind of where we're starting. But right now we're doing beta, making sure everything's streamlined and buttoned up before we push it out to you as providers and making sure our design team is well trained and versed in the overcorrection. But the goal is eventually to have these behind the scenes. So you don't have to think about it as much on the forefront, specifically just the nuances here that Dr. Lee has mentioned, not all overcorrection. So if you still need to do your deep bite overcorrections or open bite overcorrections, you'll still need to add those in based on your own preferences. But we do want to make the InBrace recommended overcorrections easier for you. So that's on our roadmap to do.
Yeah, so with it's hard for us to know exactly what your plans are for deep bite overcorrection, what auxiliaries you're going to use, say class 2, class 3 elastics. We don't know where you're going to run the elastics to. So that's why it's really hard for us to add an overcorrection for that unless it's very, very clearly written out. However, these other ones are like the nuances that we can add some, what we're calling intelligent force systems to it behind the scenes so that you no longer need to even think about it. Well, because we know exactly how to counteract it. We just have to implement for you, and that's coming in the near future.
Okay, but with that being said, you'll hear me repeating this over and over and over again. And InBrace, it's when people look at cases, the first thing I say is don't look at it and say, how do I treat this InBrace? Just look at it and say, how would I treat this period normally with orthodontics? Because 80-90% of what we're talking about is how you would treat any case when you think about overcorrections and force systems and those things. And it really is these little nuances that you have to keep in mind. And again, it's on this page that Dr. Lee has up. And, we are moving towards simplifying it for everyone and moving all the nuances to the background so that you literally just think about it orthodontically, not InBrace specifically. Okay. So with that being said, we had an awesome hour with everyone here. Thank you for joining. Next week, we're going to continue with part 3 of our webinar series, and this is going to be a deep dive into clinical cases. I know orthos love to go over cases. So, in the meantime, we're going to send out surveys. And again, those surveys are one of the most important things for us because it helps us know what's working, what's not, and what's needed for all of you. And for folks who've been with us for a while, I hope you really see that we are doubling down on these webinars and these kind of in-person education platforms to, get out the information that everyone's asking for. And it's really just through the feedback that you're giving us that we're able to do this.
And then we also upcoming study clubs I forgot to mention. So we are launching peer-to-peer study clubs. These are going to be hosted by fellow providers who will be going through cases that follow the same topic as this month's study club or this month's webinar. So each month we'll have study clubs that are related to the month's webinar. So you'll also have the opportunity to present your own cases in these study clubs with your peers. So if you are interested in participating also in our study clubs, please reach out to either your TIS or your regional sales director, and then they will get you the information on the study club because it's by invite only.
Nothing beats in-person learning, right? As much as I love seeing your beautiful faces on Zoom virtually. So, and then, lastly, if this is helpful, the best thing that you can do is tell a friend, that's doing InBrace, to join these webinars, join these study clubs, because we're not trying to hoard this information. We are trying to get it out for everyone here. So with that being said, thank you so much for joining in. Thank you for spending your evening with us, and looking forward to seeing you next week. Go in the in group, check your email. You'll see these links out there, and looking forward to seeing you again. Thank you, everyone.
There was one last question, John, about whether the webinars are being recorded. The answer is yes, they are being recorded. And I believe you can reach out to your TIS for the recording.
Yes.
Perfect.
Yeah. All right.
Great. Thank you, everyone. All right. Bye.